Hi, everyone. I'm Sorelle Friedler from Haverford College, and this is joint work with Mohsen Abbasi, Calvin Barrett, Kristian and Suresh Venkatasubramanian. I'll be talking about our work to measure and mitigate voting access disparities with a focus on the differential access to polling locations by race in the U.S. 2020 general elections in Florida and North Carolina. There's a long history of sometimes violent suppression of the Black vote in the U.S., and of course, voter suppression continues to the present day. In our study, the goal is to determine how to measure voters' access to their polling location, including being able to examine any differences by race. In this talk, I'll focus on voters' access to the polls in terms of the distance from their home to their polling location. In the paper, we also consider the load of each polling location, the number of people assigned to vote at that location. There's a decades-long history, especially in the political science literature, of measuring voters' distance from their polling locations, and especially the impact of that distance on turnout, whether voters show up to vote. The main conclusion of the literature so far is that increasing voters' distance to their polling location decreases turnout, but there are some caveats and unclear results in rural areas with the longest distance to the polls. The main methods for these studies include local, for example, single county, studies of all voters, or larger scale, for example, statewide, studies that use a discontinuity design that considers differences in turnout for voters who live close to each other but were assigned different polling locations because of nearby precinct boundaries. Those larger studies only consider voters at the boundaries of districts. Part of the complication many of these studies face is the need to control for population density. Voters in rural areas need to travel further to get to the polls. But since there are also demographic differences between urban and rural locations, this makes it hard to study voter access differences by race. In our study, we used data from the 2020 U.S. general election. Our data consists of all registered voters in Florida and North Carolina, with race, address, precinct assignment, and information about whether they voted recorded for each voter. We used ArcGIS to determine the latitude and longitude for each voter's address and polling location. We also gathered the locations of all schools and libraries in the state, which we use both for our analyses and as possible additional or alternate polling locations. Looking at a basic analysis of the mean, median, and maximum distances traveled, broken down by race in both states, we see that while white voters travel further to the polls, however, this analysis doesn't control for population density, so may just be indicating that white voters are more likely to live in rural areas and thus be further from the polls. When we consider turnout data for all voters in both of these states, we see that as the distance to a voter's polling location increases, they are more likely to vote. This goes against the results in the previous literature and indicates that we need better measurements that account for population density. One of the key contributions of this paper is the introduction of a normalized distance that can account for population density. We consider dividing each distance by the distance to the nearest school or library, as well as the distance to the nearest voter, and look at both the mean and median of both options. Since distances of voters to polls have a very skewed distribution, with a small number of rural voters living 30 or 40 miles from their closest polling location, while other voters live as close as a few feet away, median measurements make the most sense for understanding these measurements. Additionally, we found that normalizing by the distance to the nearest voter suffers from some corner cases that make it not ideal as a measurement. For example, voters in the same apartment building have a distance of 0 from each other. On the other hand, normalizing by the nearest school or library and taking the median does not suffer from these concerns and additionally allows for an intuitive understanding of the resulting normalized distance. A normalized distance of 1 is the distance a voter has to travel to their closest school or library. A normalized distance of 2 means they have to travel twice as far as their closest school or library. Using this normalized distance, we find that non-white voters in Florida have to travel further than white voters to get to the polls, while in North Carolina, these normalized distances are similar by race. When we again consider distance and turnout, but now using these normalized distances, see the bottom row here, we can see that turnout goes down as this normalized distance goes up. In Florida, for example, voters at a normalized distance of 1 had a turnout that was about 1.4% higher than voters at a normalized distance of 2. This trend matches the literature, indicating that the normalized distance is capturing the effects of the previous work, but with an easier study design that allows us to analyze turnout and voter distance for all voters. Finally, using this normalized distance as our key metric, we consider a variety of algorithms for placing polling locations so as to lower voters' distance to the polls and evaluate them based on race. These novel algorithms are extensions of techniques for fair clustering and are adapted to handle the large scale that is required, given that each of these states contain millions of voters. Details of the algorithms and resulting analyses are in the paper. Overall, I want to emphasize that using schools and libraries as realistic alternative polling location options, we are able to reduce voters' overall distance to the polls and also reduce racial disparities in those distances. Better polling location placement is possible. Thanks.